We're going to show you what's involved in replacing a carbureted intake system with a Borla induction system and electronic fuel injection. Doing the installation is Tom Habjek of EFI West, with help from yours truly, David Borla. The installation is being done on a Shelby Cobra, but the procedure shown here can translate to most any vehicle where you're replacing carburation with electronic fuel injection. First, the obvious differences. With a carburetor, the air-fuel mixture goes into a large plenum where a charge is drawn into each cylinder during its intake cycle. With the Borla induction system, each cylinder is treated independently and a timed pulse sent into the intake runner at the appropriate time. The primary advantage is that the cylinders can be individually tuned for optimum performance along the entire RPM range, while the ECU also makes adjustments in real-time tuning. We started the build by baselining the 427 cubic inch carbureted engine on EFI West's DynoJet chassis dynamometer. A maximum of 396 rear wheel horsepower was attained at 6,000 RPM. In preparing to convert any carbureted engine to fuel injection, the first place to start is fuel delivery. Most carbureted engines on the street can operate just fine on 4 to 5 pounds of fuel pressure and typically rely on mechanical pumps. Fuel injection demands much higher pressure, as this is what helps atomize the gasoline for improved performance. We're using a Bosch electric fuel pump in our installation that has a 100 psi rating, but we're using a regulator to bring it down to 58 psi at the injector rails. For the Cobra, we've determined that the best place to mount the pump is on the main frame rail, essentially beneath the driver. We're also installing a fuel filter on the inlet side of the pump and another one on the outlet side. We don't want any impurities getting into the injectors. It's also important to use the correct sized fuel lines from the tank to the pump and from the pump to the injectors. We've used AN-8 braided lines. You'll also want to test the pressure. Next, we remove everything relating to the carbureted intake system, essentially leaving us with a long block. And because of the unique design of the Ford FE engine, we have to also remove the rocker arms. On vehicles with electronic ignitions, such as this continuation Shelby Cobra, we can use the original distributor. However, you must disable the mechanical advanced functions. For older cars with a point-type distributor, we would need an upgrade. You'll want to remove the old intake gasket and prep the cylinder head surface. Use caution to prevent debris from getting into the ports and valley. After tacking the new intake gaskets into position by using RTV silicone around the water ports and to the front and rear block end rails, carefully place the Borla induction manifold into position on the cylinder heads. Because all of the fasteners that originally came with the motor were not compatible with the new manifold, we opted to use polished stainless steel ARP bolts and ARP fastener assembly lube. We applied 15 foot-pounds of torque as our fastener preload. Individual fuel injectors are the heart of the system, and they come in different flow rates. For the 427 cubic inch engine in the Cobra, we're using injectors that are rated at 50 pounds per hour. They're lubricated and slipped into the injector bodies. Then we assemble and install the fuel rails. Then we'll install the injector bodies onto the manifold and slip the distributor into position. The brain of the system is the engine control unit, which will be custom programmed for the application. This procedure is called mapping. The ECU also gets necessary information from the throttle position sensor that attaches to the manifold and oxygen sensor that's plugged into the exhaust system. The throttle cable attaches to a bell crank on the Borla induction system. Other data that the ECU uses to compute the fuel pulse includes engine temperature, voltage, and engine speed. In the Cobra, we're using a fast controller, a special wiring harness that has been developed by EFI West for this particular application that makes it a true plug-and-play installation. After hooking everything up, it's time to do the preliminary mapping and fire up the engine. Then, we're going back on the EFI West chassis dyno for two reasons. One is to fine-tune the fuel curve with the engine on a load. The second is to do a couple pulls and see how the Borla induction system performs. As you can see, the Cobra now puts out 417 horsepower at 6,000 RPM. More importantly, The torque curve has improved to provide a wider, more level power band, which is important for all-around driving performance. Add to this the visceral good looks of a race-bred port injection when you open the hood, and it's easy to see why a Borla induction system is the way to go. For additional information on this and other Borla induction systems, visit us online at www.borlainduction.com.